Before diving into the implementation and explanation of the state manager, I would like to show you a small demo of what we mean by state management and what is the functionality of the state management. So what we really need is a way to restore the state of some objects. And the most basic object that you can imagine is simply the integer itself, right? So in Java, we have the integer like this. So we would like to have something similar to an integer, to the primitive time integer, but that should be able to restore itself on backtrack. And so to create that, we will use the state integer object instead, which is pretty similar to a simple integer, a primitive time or an integer object in Java, except that it is able to restore its state on backtrack. Okay. So the way it works is that you use the state manager, and there are several possibilities. One of them is a trailer. Okay, you don't need to understand the details yet. You use the factory method make state integer, and you can give it an initial value like this one. Okay, and then you can modify this value with the setter method, and then you can just print it. So if you print, you do get value or value, and you have the result that you expect. Okay, which is, so you just set it to 7, A to 7, B to 13. So if you print it just after, when you will execute it, as you can expect, you will see 7 and 13. Okay, 7, 13. So exactly what you expected here. When it becomes interesting is when you use really the state manager functionalities, which is you would like to be able to store the state of an object. So if you would like to store the state of an object, you take the state manager and you say, I want to save the state. Okay, and this will allow you to do and undo stuff. Exactly when you do Control Z and you want to undo something inside your best editor, this is exactly the same kind of behavior that you have. So what you will do here in that you will save A equal to 7 and B is equal to 13. Okay, this is, you remember. Okay, you will remember it, and then you can continue to modify the object. For instance, you can set A to another value, let's say 20. Sorry. And then you set, for instance, B to 1. You can print it again. And as you can expect, you will see 20 and 1. Okay, 21. But just after you have set it the values to the new values, you could have decided to restore the state as it was in the last save state. So you could do state manager dot restore state. Okay, and if you restore the state, you will see exactly the state as it was there before. So A was equal to 7 and 13 at the time of the capture. Okay, so this is the behavior that you expect, and we can check it together, and you see that we have this. Okay, and you can do it consecutively like this, save state, restore state, but you don't need to do that. What you could have done is, again, save the state here, modify it again, let's say to 5 and 5. Okay, and so if you if you save the state here, it means that it was equal to 20 and 1. Here it was equal to 7 and 13. Okay, so if you restore the state once, you will come back to the state when it was to 21, like this. But if you restore the state 2 times consecutively, you will come back to this previous state. Okay, it's exactly like a stack. You set the state, and the state is stacked on top of the stack of states. And when you restore the state, you unstack the state and you restore it as it was before. Okay, so it works really like a stack of states. Okay, and this is exactly like undo. You undo, and then you undo again. Okay, so if you undo this one, you come back to this state, and if you undo one more time, you come back to this state. So this is the way it works, the state manager. And what I will explain now is how we implement this mechanism inside a mini CP.